Hello and welcome to my YouTube channel. I'm so happy you are here with me today. My name is Veronica, known as Data Geek. So if you're looking to learn SQL and Python for data analysis, you are in the right place. So we will go over how to use SQL inside Jupyter Notebook using Python code. In today's agenda, we will create a SQLite database. Then from that database, we will insert sample data and we will run SQL queries inside Jupyter Notebook using Python code. So we'll learn how to store, retrieve, and analyze data using SQL. We'll use SQLite. This is a lightweight database system. We will run SQL queries directly inside Jupyter Notebook. And then we will load SQL results into a Panda data frame for analysis. Then we will perform data visualization, the fun part, based on SQL query results. This tutorial will help you get started step by step, so grab a cup of coffee. And first we will begin, what is SQLite? So if you have not heard of it, SQLite is a lightweight database system that lets you store and manage data without needing a separate database server. So it's perfect for small projects, prototyping, and learning SQL because it doesn't require installation or setup. It runs a single file on your computer. So it has zero configuration, so no setup is needed. You work immediately. It's self-contained, stores data in a single .db file. It's fast and lightweight, great for small to medium data sets. And SQL powered, supports queries, tables, joins, and indexing. So think of SQLite like an Excel file that uses SQL commands instead of spreadsheets. So why use SQLite with Python? So there's no extra setup needed. It's built into Python. You can store structured data easily like spreadsheets, but better. It works well with Pandas. You can load SQL results into data frames for analysis. It's great for small projects, so no need for big database servers. So in short, SQLite plus Python lets you store, retrieve, and analyze data easily using SQL commands, all from inside Python code. So let's get started. I will see you in the Jupyter Notebook. Okay, so here I am in Anaconda. So I use Anaconda Navigator to run my Jupyter Notebook. So if you're not sure how to download Anaconda Navigator, I will put a link in the description below for you to check out, giving you a step-by-step instruction on how to download Anaconda Navigator. So from here, I just click on Launch for Jupyter Notebook. So once my Jupyter Notebook is opened, I will then go ahead and click on New and Python 3. This will open up a new workbook. As I always mention, you can always title this whatever you want. Up here where it says Untitled, just simply click there and title this. I am going to title this SQLite and Python. And I'm going to hit Rename. Now it will change to that new name I just changed it to. So in your first cell, what I want to do is I want to go ahead and do a step-by-step. So in step 1, I will install and import required libraries. So again, this is not a code, so I'm going to go ahead and click up here to Markdown. And if I run this, it will run as a Markdown, not a code. But if I want to make the text bigger, I simply just double click in here and I will put a number sign in front of that. And the more number signs you make, it changes the size of your text. So I'm going to do a Shift Enter and it's bigger. So I'm going to zoom in so you can see better. So in my next cell, we will go ahead and start our Python code. So making sure this right here is selected as code. And I'll just put a note. So any notes would start with the number sign, and then install. I'm going to do SQLite first. And I'm going to do the 3. So this comes with built in with Python. Okay, so the code for that, just to install it, if you're familiar with Python, it's just import SQLite 3. So this is how you import that SQLite. Before I run my code, I have other libraries I want to install. So this one is I want to install Pandas for data analysis. And to do that, again, I'm going to do import Pandas as PD. So as you can see, it's reading this as a code. And like I see, that number sign is just a note. So I'm going to go ahead and enter just to move down. Next, I want to install Seaborn and Matplotlib for visualization. So install Seaborn and Matplotlib for visualization. Okay, and to do that, I'm going to go import, and you guessed it, matplotlib.pyplot as plt. Making sure I spelled that right, because if I run the code, it will give me an error. So that's matplot lib.pyplot as p. Yes, that's correct. And next I will import Seaborn, Seaborn as SNS. Now my last thing I want to do is this method hides any warnings in your Jupyter Notebook. So this method hides any warnings in Jupyter Notebook. So sometimes when you run a code, you might get a little warning sign and it shows just basically your path, something like that. So instead of just seeing that, I want to just go ahead and ignore that warning. So that's what this is for. So import warnings dot filter warnings and ignore. ignore. And you close that with the parentheses. So now I will go ahead and run my code. You can simply click on this play button to run your code. Now that it changed to a number, you know it ran smoothly. So now we just imported all of our libraries. Now we're going to go ahead and go to step 2. And here we're going to create a new SQLite database and a table. So this part here, I want it to be a large caption like this one. So again, what do? Do you remember? Yes, you are right. We put a number sign in front of that, space. Now here we change this, instead of code, we do markdown. And I will run that. So in step 2, we're going to create a new database and define a table to store customer ID. So I like to start off with my notes. So I'm going to do a number sign there. Connect to SQLite database. So this creates a new file if it doesn't exist. And that code, we're going to call it CONN, short for connect. So now we will use the code SQLite3 dot connect. And we want to name this customer underscore data dot DB. So you can name this, again, whatever you want. I'm just calling it customer underscore data, for the DB is database. So I forgot double quotations here, and close that with the parentheses. So next note I want to do is create a cursor to interact with the database. And I'm going to call it cursor equals, and then I will use the code CONN dot cursor, open and close parenthesis. My next note, I will be creating a sample table. We're going to be using the code cursor.execute, open parentheses. So the cursor.execute function is used to run SQL commands inside Python using SQLite. So think of it as a way for Python to talk to the database. So when you run the cursor.execute command, Python sends an SQL command to the SQLite database so it can process it. So we're going to go ahead and execute a SQL command to create a table. So we're going to start with 3 double quotations. That's 1, 2, 3. And then within here, we're going to go ahead and use the SQL command, which is create, all uppercase, table, if not exists. And we're going to call this table customers. This is the customers table. So again, it's create table if not exists. And we're naming this customers table, which anything that we name within the SQL commands, we will go ahead and put it lowercase. So this is our table name. So I'm going to go ahead and start creating our columns. So the first column is going to be ID. Since I'm calling this column ID, it's going to be lowercase. So the next, I'm going to do a function, which is going to be uppercase, integer, primary key, auto increment. So I'm basically saying that we're going to put this ID column is going to be our primary key. So the next column is name. So we put it lowercase. And then a command for SQL is text. So if I don't know, not sure if you know what I'm doing here, but this is basically assigning a data type. I'm not sure what a data type is. It's kind of data that can be stored in each column of a database table. So when we create a table in SQLite, we assign data types to each column to specify what kind of data it should hold. And that's what we're doing here. So we want to make sure the name is an actual text. So next one's going to be age, and we want it to be an integer. And then the next one's going to be city, and we want it to be a text. And the next one's going to be total spent. And we want it to be real. So I'm going to close that parentheses. As you can see, it highlights the one that opened. So then the next thing I did was 3 quotation marks. So I'm going to close those quotation marks and then close with another parentheses. As you can see, it matches up with those. Next, I'm going to commit and close connection. It is CONN dot commit. Open and close parentheses. And I will go ahead and hit run. And I got a number, so it ran smoothly. So now we have our table ready to go. We will change that to markdown and we will run this. So this is going to be sample data to insert. I'm doing a bunch of typos here. So it's going to be in our customer data. Now each one of these has to do an open parentheses when you're using text, it's going to be a double quotation. So I'm going to use text for the name. So the name is going to be Alice Johnson, comma, and the next we have is age up here. So the age is going to be 28 years old. The next column is city. So she's going to be in New York, comma. So as you can see, I'm separating each statement with a comma. And then total spent is going to be 500.75, close parenthesis, comma. We're going to enter another one. So this one, a text again, so it's going to be Bob Smith, comma. Let's say he's 35, from Los Angeles, comma, and 1200.50. Close that with parenthesis, comma. Next one is going to be Charlie, double quotation, Charlie Brown. And Charlie Brown is 22. See what happened there? Still reading it as a text because I didn't close that with a double quotation. So there we go. 22 years old, from Chicago. Double quotation, comma. 330.40. Close that with the parentheses, comma. And let's do a David White. Age is 40, comma. And Houston. 980.90. And you can see this is really good when you have a small data set, especially if you want to create your own tables and insert your data. Now I see what I forgot here. I forgot a bracket. So after the customer, which making sure your now making sure your table name is correct, and identifying it here. So customer, I'm going to copy, making sure I put customers up here. So now it's not going to read it. It's going to give me an error. So I got to make sure I spell this right for it to identify that table. So customers, and then right after that, you're going to do an open bracket. Then down here at the end of your table, you do a close bracket. So it stays within your brackets. I'm going to insert data into table now by using this code. So it's going to be cursor dot execute many. Making sure I spelled that right. EXECUTE MANY. Okay, making sure it's spelled right. Otherwise, you'll get an error message. Open parentheses and double quotation, and I'm going to go insert into. Now it's case sensitive, so make sure your customers, again, is spelled right. So I'm going to do a Control C, Control V to make sure I have the correct table and spelling is correct. Open parentheses, name, age, city, total underscore spent. So again, we need to make sure these are also correct spelling for your columns that you created up here. So first one is name, age, city, total spent. These are going to be values. 4 times, these question marks, comma, and then again, Control V for customers and close that with the parentheses. I'm going to do a commit changes. By doing CONN dot COMMIT, open and close parentheses. Now I will run my code and it gave me a number, so it ran smoothly. No errors. Okay, so step 4. So now that we went ahead and installed our required libraries, right? In step 2, we did a database table using SQLite. And step 3, we insert the data into a SQL table. Now step 4, we're going to run the SQL queries inside Jupyter Notebook. And I will add some more cells here. So again, I'm going to start with my notes so we know what we're doing. We're going to run a SQL query to retrieve all customer data. So we're going to name this query Query equals, and we're using a SQL command, which is select, and then that little asterisk, the star, which means select all from, and our table name, customer, with an S, customers. And then we're going to call this df, and we want it to equal to pd.read underscore SQL query CONN. Close that. So this stores query results in a Panda data frame. So I can put that note here. So next we're going to go ahead and do is display the data by just calling this down here, df dot head. Open and close parentheses. That's how we print and view our data. So I'm going to go ahead and run that. And now you can see everything we inserted into this table, we inserted text, and now you can view it. So this query is select all from customers. So it's showing you all of the customers, but then down here you're selecting the head of the data. So if you had a whole lot more, it's just going to show the head, but still showing you all customers' data, if that makes sense. But Alice Johnson, 28, Bob Smith, 35, Charlie Brown, 22, and so on. So that is how to run SQL queries inside Jupyter Notebook. Next, step 5. Perform data analysis using SQL queries. Change that to markdown, Control Enter if you're using Windows. So we're going to create a query. And we're going to use a SQL command, which is select your star, which is all from. So select all from, and we're going to use the customer table. So again, I like to copy customer table name and paste it here. So Control C, Control V. That way I know it's spelled correctly. Where, and I want to use this total spent because we want to, again, pull anything that's over $500. Total spent column, more than 500. dd dot read underscore SQL query, comma, CONN. Close that with the parentheses, and I will run my code. It'll show me all my data that's the total spent is more than 500. So you can just kind of visualize it. Anything over 500 is now listed. Now, if you want to do under 500, you just change that the other way, and we can run that code. And now you can see all the data that's under 500. So let's find the average customer age. So I'm going to just do a little note here. Query, again. So every time you want to use your SQL code, you have to use it as query equals, double quotation, and then now select AVG, which is short for average, and then your column name. So it's AGE as average underscore age from your customers table. So I'm going to do Control C and Control V and double quotations to close that. And again, I want to use this code here again. So do a Control C to copy and a Control V to paste. And now run that code. It will give you the average number, which is age, within that column. And that's the age column. That's where we specified it here. So it's grabbing that column there. Say you want to count customers in each city, so you can do that too. Again, you start with query equals double quotation. We want to select city, which is our column name, variable name. We want to count, open parentheses, star, which is all, as NUM underscore customers from, again, customers. You want to group by city. Close that with quotation. And again, we want to use that same code here at the bottom. So I want to highlight that, Control C to copy, and to Control V to paste. And let's run that code. Now you will see that our query is working to select all numbers from customer, and we're grouping by city. So now our fun part, we are going to do a visualization in step 6. And this is going to be a markdown, Control Enter, and I'm going to add more cells by clicking this plus sign to add more cells. So what I'm going to do is I'm going to create a bar chart showing the total amount spent by customers in each city. So the first thing I want to do is I want to run SQL query and store results in a data frame. So this is the part where I'm going to do that. So I'm going to start off with query equals double quotation, then do your query command, select your city, which is your column name, an SUM, sum. We want to sum the total spent, underscore spent column, as total underscore sales from your customer table, from your customers table, from customers. And then we want to group by city. Close that with double quotation. And then we're going to do a df underscore sales equals pd.read underscore SQL. And it's going to be a query, comma, CONN. Just want to run this, making sure it works. And it did. Click back into this cell here and just continue with my code. So I want to put a note here. Plot the data, because that's what we're going to do next for our bar graph. PLT dot, and then figure, FIGURE. Open your parentheses and put FIG size equals, open parentheses, 8, comma, 5. Close that up and enter to go down. Then SNS.BARPLOT This is going to be your X and Y axis. So my X axis, I want it to be my city column. And my Y axis, I want it to equal to my total underscore sales column. And it's going to be data equals DF equals sales, which this is what we called it here. So it's going to read this code to kind of identify the X and Y axis, pulling in that data. Now this is the color scheme. So I want it to be equal to like a cool, warm color. Close that with the parentheses. Now PLT dot X tricks rotation equals 45. Now PLT dot title. Now this is your title. I want to name it total sales by city. Again, it's a title, so you can name whatever you think is good for your analysis. But in this case, we are trying to identify total sales by city. And then now I want to show my bar graph. So I'm going to do plt.show, open and close parenthesis. Now I'll run this again. And as you can see, I ran this code up here, so that I know it's not this code. But down here on the bottom, it's saying invalid syntax. So df, oh yeah, I can already see, data equals, which is right here. And I put equals instead of an underscore. So data equals df underscore sales. So I will run that code again. And name X is not defined. Oh, I put a comma instead of an equal signs there. So X equals, and then your variable, which is your column name. Same with your Y. See, Jupyter Notebook will let you know when you have any errors. Okay, so it did run my code. However, it does tell me that it does not have any X tricks, and it's because, again, I messed up. I spelled that wrong. So XTICKS. Control Enter, and there we go. Now your code should be good to go. Once I run that, you will see your total sales by city in a bar graph. This is what I called my bar graph, which is here. But again, if I change that, it will change the name here. So if I put just total, like I'll just show you an example and run it, it will just change that to total. But I want it to have total sales by city. So I'll run it again, total sales by city. So that's the title. Total sales here is what you're calling your y-axis. And your x-axis, you're calling city. It's grabbing your city column, which is Chicago, Houston, Los Angeles, New York, San Francisco. As you can see where the higher sales are in what city. Now that we're done, it's good practice to close your connection with SQL. So to do that, we'll just go ahead and put step 7. Close the SQL connection. And it's real simple. Just put CONN, which is short for connection, and close. Open and close parentheses and run your code. So we created an SQLite database inside Jupyter Notebook. We inserted customer data and queried it using SQL. We combined SQL and Pandas to analyze data, and we visualized SQL query results with Python using a bar chart. Now that you know how to connect the SQLite database into a Jupyter Notebook, maybe now you can start using your own SQL queries, or better yet, connecting your own database to explore more possibilities. So if you don't mind, please like my video, also subscribe, and also maybe drop a comment. What was the biggest takeaway for you, and what do you want to learn next? Again, I hope you enjoyed my video. Thank you for watching, and I will see you on the next video. Happy coding.